All right, so what you're doing with 6.1 is factoring these equations. So what you, for the most part, what you want to do is factor out what we call the greatest common factor. Now, if you've gone to the assignment already and kind of asked them for help, or even if you viewed the PowerPoint, a lot of what they do is what we call that prime factorization. They break things down into their prime factors, and that's fine. You can do it that way. That's not really necessarily how I teach it or how I do it. But the way I teach it kind of requires that you kind of have a pretty good understanding of multiples of various numbers and the factors of various numbers. So if you look at example 1, usually in these problems, you want to factor out our constants or our coefficients. You can look at our coefficients. In this case, we have a 7 and we have a 21. Many other examples are also going to have variables. So at some point, you'll look to see if they have common variables that you have to be factored out. And by that, I mean, so we have an x here, but we don't have an x here. So I can't factor out x's in both of these. Okay, so remember, each term, kind of has to have, you're factoring out kind of the most you can from each term. So when you're looking at this problem, when we start with the number, so I mean, yeah, they both don't have an x. So really all we're looking at is that 7 and the 21. And what is the, greatest common factor? What is that GCF between 7 and 21? And the answer is 7. 7 is the highest number that will go into 7 and 21. All right. So then I like to kind of write, you put that GCF outside that parentheses, okay? Because that's what we're going to take out of each of these. In other words, we're dividing 7 into each term. What are you going to be left with when you do that? Well, 7 divided by 7 is just 1. So the 7's actually cancel out. So all I'm left with there is x. And then what's 21 divided by 3? 21 divided by 7 is going to give me 3. So that's how the factored form of 7x plus 21 would look like. Remember, you can always check that by just distributing the 7 back in. In other words, 7 times x would give me 7x, and 7 times 3 would give me 21. So that's that factored form of 7x plus 21. So let's do some with variables. All right, so we talked about these coefficients would be something we'd have to factor, and then the variables. Well, in this case, this coefficient is 1. So between 1 and 6, the biggest thing you can factor out is 1. You can't say 6 because 6 won't go into 1, but 1 will go into 6. So there's really no number that I'm pulling out of x to the 4th, 6x to the 3rd. So now we're looking at the variable. So what is the most, or the most amount of variables I can pull out? Okay, so this one has 4 x's, and this one has 3 x's. So the most I can pull out would be 3, because yes, I can pull out 4 out of this one, out of this term, but there's not 4 x's I can pull out here. Okay, and that's one of the slides of the PowerPoint that I, looking over it, that I thought was really important. It takes a little while to kind of figure this out. Okay, remember that GCF of a list of terms contains the smallest exponent of each common variable. So if you look at this example here, there's 3 different terms: x to the 3rd, y to the 5th, x to the 6th, y to the 4th, x to the 4th, y to the 6th. So what this is saying is I can only pull out the smallest amount of the exponents they have in common. In other words, let's look at the x's, just the x's. Okay, there's 3 x's here, there's 6 x's here, and 4 x's here. Okay, so if I'm trying to factor out, or what is the greatest common factor of these 3, just again talking about the x's, okay, it would be x to the 3rd, because that's what they have in common. It's the smallest amount. Okay, you can't say there's x to the 6 because there's not 6 x's here. Okay, there's only 3. You can't say x to the 4th because there's not 4 x's here. It's only, it's what the most they all have in common. The most they all have in common is always going to be the smallest amount. Okay, if that makes any, hopefully that makes sense. Okay, and then when you go to your y's, let's look at our y's. Y to the 5th, y to the 4th, y to the 6th. Again, my greatest common factor is going to be the smallest exponent of y's, which in this case would be y to the 4th. Because that, again, is what I am factoring out. I can't factor out. I can't pull something out that's not there. Okay, so I can't go more than y to the 4th because there's only 4 that I can pull out here. I can't pull out 5 if there's only 4. Hopefully that makes some sense. So going back to this problem, okay, we already determined I cannot pull out a number. So all I'm pulling out are my x's. And how many x's can I pull out? Again, I can pull out the smallest amount, which in this case would be x to the 3rd. So that is what my GCF is. I can't say x to the 4th because where am I going to get that 4th x if there's only 3rd? If there's only 3 in this one. All right, so if we know our GCF is x to the 3rd, so really what we're doing is that's what we're dividing. That's what we're factoring out. So in other words, you're dividing each of these terms by x to the 3rd. So how many x's are left if I'm taking 3 out of x to the 4th? Again, it's 4 take away 3, would just leave me 1x. Here, all the x's are going to cancel out. And what am I going to be left with? I'm going to be left with plus 6. Again, if I distributed back in, x to the 3rd times x would give me x to the 4th. X to the 3rd times 6 would give me 6x to the 3rd. All right. And that's kind of how we're going to do these until we get to the grouping. When we get to the grouping, I'll explain that. Let's get into some more examples. All right, so x to the 3rd actually has 3 terms in it. First thing you should recognize, this has an x, this has a y, and this is a constant, so this has no variables. So in this example here, I'm not going to be able to pull out any variables. Okay, so all I'm really looking at are these numbers, 9, 63, and 9. And what would be the greatest common factor they have in common, or what's the highest number that will go into all 3? And the answer to that would be 9. 9 actually goes into all 3. So that's what I'm factoring out. So that's what I'm going to be pulling out of each term. I'm pulling out 9 from each term. In other words, I'm dividing each term by 9. And the hardest part of this is just coming up with that GCF. So here the 9's cancel out, and all I'm left with is x. This is 63 divided by 9, which would give me 7, and you keep the y there. And then this is just where you got to understand, if everything's gone, okay, so 9 divided by 9 cancels it, they cancel out. You got to put something there. You can't just leave it blank. 9 divided by 9 is actually 1. So even if I'm dealing with variables and all the variables factor out, I have to put 1 in there. And again, the easy check is if I go back the other way, 9 times x gives me 9x, 9 times negative 7y gives you 63y, 9 times 1 would give me the 9. Do another one with 3 terms. Actually, this is a good one because we're going to have to factor out a number and a variable. All right, so the first thing again we have to do, and you'll see I'm actually writing what my GCF equals. Once you determine that, I mean, if you want to just write it down here, that's fine as well. So I looked, just quick glance, I got numbers, okay? Anything that's multiples of 5, I know I can pull out 5. Okay, so 35, 25, and 40, we know 5 goes into all of those. And then I know they all have a common variable, so I'm going to be able to pull out a variable as well. But as far as that coefficient, that number, yes, 5 is the biggest number that will go into all 3 of these. And then going back to these variables, how many x's can I pull out? There's 4 here, there's 2 here, and there's 1 here. Again, I can only pull out whatever that smallest amount is, which means I can only pull out 1 x. I can't pull out x squared because there's not 2 x's here, there's only 1. Okay, so again, I can only pull out whatever that smallest amount is. So my GCF is 5x. Again, what does that mean? That means I'm pulling out 5x from each one of these terms. In other words, I'm dividing 5x into each of these, and that's what I'm going to get inside my parentheses. So 35 divided by 5 would give me 7. And I'm dividing, there's 4 x's and there's 1 here. So if I pull an x out, I'll be left with x to the third, or 3 x's. 25 divided by 5 gives me 5. X squared, I'm pulling 1 out, so that gives me x. And then 40 divided by 5 gives me 8, and my x's are gone, so you don't write x to the 0, you just write 8. Close the parentheses. And again, if you worked backwards on this and distributed back in, you would come back to the original problem. All right, 5, when you originally look at it, it looks a little tough. Again, if we do it step by step, it's not so bad. All right, so we have A's and B's, and we look, they each have A's and they each have B's. All right, so that when we're determining our GCF, we got to see how many A's can I pull out, and then how many B's am I going to be able to pull out. So let's start with the A's, okay? 5 A's here, 3 here, 2 here, and 2 here. Okay, so again, it's my GCF, and I know it's hard because you see greatest common factor, you want to try to pick the biggest. Yes, you want the biggest, but when you're dealing with variables, the biggest one that they have in common is actually the smallest, okay? So I can only pull out 2 A's, A squared, from all of these. I can't pull out any more A's because there's only 2 here and here. Okay, if I try to pull out 3, where am I going to get that third A from? Yeah, I can pull out 3 here and 3 here, but I can't pull out 3 here and here. Okay, so the most A's I can pull out are A squared. And let's look at the B's, 6 here, 2 here, 4 here, and 2 here. So same thing, it's got to be the B squared. So that's my GCF, A squared, B squared. That's what I'm going to have outside my parentheses. Again, what does that mean? That means I'm dividing A squared, B squared into every single one of these. And whatever's left after I do that is what I write in the parentheses. All right, so there was 5 A's. I'm taking out 2. How many are left? 3. There were 6 B's. I'm taking out 2. 6 take away 2 would give me 4. Come to the next one. There was 3. I'm taking out 2, so that means 1's left. B squared, I took both B's out. So again, those cancel out. Come to this one. Took all the A squares out, so the A's are gone. And then 4 take away 2 would leave me B squared. And then this last one, just be careful. There was 2 A's and 2 B's, and I took them all out. So everything's gone out of here. So what do I have to put in? What do I put in its place? In this case, since there's a negative there, it would be a -1. Okay, again, when I distribute back in, when I get to this last one, if I don't have anything there, how am I going to get A squared, B squared? That's why I need that 1 there. So again, you can always check it, double, put everything back in, and it'll take you right back to the original problem. All right, so when we get to 6, we're going to start our grouping. It's actually going to be grouped for you. But they want to make sure you understand what we're dealing with. All right, so what I want you to recognize is that x squared plus 4 that we have right here is the same as this right here. You see, both agree, right? These are the same problem. So if this is what they both have in common, I can factor this out. Okay, I can pull this. In other words, I can divide x squared plus 4 into both of these problems, right? And then this would cancel out, this would cancel out. All right. So if I'm pulling out an x squared plus 4, what's actually left? Well, I'm left with y plus 9. So again, if that's the same, that's what I pull out. And then what's left once I pull that out is just whatever's in front of those same parentheses there. All right. So that's just kind of setting up what we're going to do when we get to these problems that they tell us to group. And then how are you going to know that is a grouping problem? There's really two ways you're going to know. So this problem right here is a grouping problem. And how do I know it's a grouping problem? First of all, you'll recognize there's 4 terms involved. 1, 2, 3, 4. The next way you're going to recognize is actually in the problem, it's going to say solve this problem by grouping. So it's actually going to tell you solve it with grouping. And the way you do grouping, okay, is you take your first 2 terms, and we're going to have to factor out the GCF the first 2 terms. After we do that, we take the next 2 terms, and we factor out our GCF there. And if we did it right, it's going to look like this here, where you're going to have these same items left in each of the terms, okay? So let's just go to this first one here. What is my GC? What can I factor out of x to the third plus 3? Well, I can't factor out a number because the number here is 1. So I'm really only looking at the variables, okay? And so the GCF here that I can factor out would be the x squared, okay? Because again, it's the smallest amount. So if I factor out an x squared, okay, so I'm taking that out of each one. If I take 2 x's out of x to the third, I'm left with 1x. If I take x squared out of here, I'm just going to be left with 3. Okay, and basically what I'm saying is when I get over here and I factor out my GCF, I better have an x plus 3 there as well. And that's how I know I factored it correctly. What you got to watch for is the sign between that second to third term. Okay, if that sign is negative, I must factor out a negative value. But in this case, it's positive. So what is the GCF between 8x plus 24? Well, they both, this one, we both had variables. This one, we both don't. They both do not have variables. There's only an x here. This one does not have an x. So I'm just looking at the numbers, 8 and 24. What's the highest number I can take out of 8 and 24? And that answer is 8. So I'm factoring out 8. I'm dividing 8 into both of these. Well, if I take the 8 out here, I'm all left with this x. And you're basically doing 24 divided by 8. And that would give me 3. Again, the way it's kind of reverse factoring. Again, if I went back in and put that 8 in, it would give me back to the 8x plus 24. The key with this grouping is after I do that, what do we notice? I have the same. When you do this, you don't have the same thing on both sides, then you probably didn't factor it correctly. But since I do, that is what I'm going to pull out. I'm going to pull out that x plus 3. And when you pull that out, what's left? So in other words, this is gone because I factored it out. And I'm just left with x squared plus 8. And we're going to do another example of factoring. All right, let's look at this one. Again, how do we know that we are using grouping? It'll tell you on top of the problem, solve it with grouping. This is kind of the first thing I do. I kind of put these little brackets below, which tells me I'm going to factor out the GCF of this one, and then I'm going to factor out the GCF. So it's like 2 separate factoring problems. 5x plus 20, what goes into both 5 and 20 would be 5. And that would leave me x plus 4. Okay, because again, we're dividing 5 in both of these. 5's cancel out, leaves me the x. 20 divided by 5 gives me the 4. If I have a plus sign, I could write a plus. If it was negative, I'd have to factor out a negative value. I have xy plus 4y. Okay, so they both don't have an x. What do they have in common? They both, hopefully you recognize, they both have a y. So I'm going to factor out a y if there's not a number that they have in common. When I pull out the y, it's just going to be what's left. Okay, it's going to be x plus 4. Again, when I do that, now I have x plus 4 in common. That's what I'm factoring out between these two. And when I factor out the x plus 4s, what am I left with? I'm left with 5 plus y, and I can just put those in parentheses as well. And then just, I had one more example I wanted to do. All right. Again, deal with the coefficients and numbers in front, 32 and 54. So I'm looking for the highest number they have in common. And sometimes that requires a little work. You can kind of put that stuff in your calculator and see. But once you do, you're going to figure out it went to that basic thing where basically I had two even numbers. So the only thing I can factor out of that would be 2. And then we're going to look at these variables and what variables do we have in common? Okay, well, they both have an x, so I can probably pull out one of those x's. I can only pull out one x because there's only one here. But I can't pull out a y because this does not have a y. So my GCF on this problem would be 2x. That is all I can pull out from each of these. So again, some of them I didn't actually show this because I probably didn't have the room. But again, it's what's happening here. You know, like when I'm pulling out that 5, I'm dividing 5 into each of these. When I pull out that y, so I don't always show it, but hopefully you guys understand what we're doing when we do that. All right, so 32 divided by 2 is going to give me 16. The x's would cancel out, and I'd be left with y. There's a minus sign there, so I keep that minus sign. 54 divided by 2 would give me 27. There was 2 x's, I'm taking 1 out, and that leaves me with 1x. And you could always kind of check to see if is there a number that goes in 16 and 27 besides 1? No, there isn't. So I know I factor that. My variables aren't the same. So again, I feel pretty confident with my answer there. So again, factoring, this is 6.1, greatest common factoring and factoring by grouping.